I'm going to briefly demonstrate how to use an interactive simulation that looks at chemical equilibrium for gas phase reactions. This simulation allows you to choose reactions where the mole changes. So in this case, we're looking at, if we look at the figure below, we start off with 5 moles of A, and then we let the system go to equilibrium. We're at 1 temperature. And in this case, the example shown, A goes to 2B. So we end up with 2.9 moles of A and 4.3 moles of B. We also have added inert because inert affects the equilibrium when we're at constant pressure. We can change the pressure in the simulation. For a constant pressure system, we also can look at constant volume, and we can then change the volume, again, starting with 5 moles of A, and we can look at what the equilibrium conditions are. So let's look at this simulation and observe the behavior. So here we start again, 5 moles of A, no inert. As I increase the pressure and I push the reaction towards reactants because decreases the number of moles. If I add inert, then it starts shifting towards products as we're decreasing the partial pressures. And then I can look instead at a reaction where 1 mole of A forms a half a mole of B. In that case, if I increase the pressure, I shift it towards the product B. We can also look at constant volume system. And now you'll notice if we add inert, it makes no difference because we're not changing the partial pressures. If we increase the volume, then we're shifting towards A. Whereas if we look at reaction A goes to 2B and we increase the volume, we shift towards B, all based on Le Chatelier's principle. So hopefully this simulation gives you a little better idea of how reactions change as we change pressure or volume, depending whether constant pressure or constant volume, and also depending on whether we increase or decrease the number of moles as reaction proceeds.